Okay. Okay, guys. So I guess we can start. Let me just share my screen, and someone just confirm whether you can see my screen. But yeah, you can see my screen, right? Okay. So just let me know if you cannot see my screen. I'll just reshare, or we can start with the topic. So okay. So let's other join. Meanwhile, you can just start or kind of give a recap of whatever has been taught in the last class, and then we will go forward with the next material. Okay. Right. Okay. So in week 7, I guess we touched upon classes a bit, right? So uh, first of all, the week 6 we explored recursion and looping, how they are different and all. Then we moved to classes. So how we can implement or how we can think in terms of objects and kind of write classes according to it, right? Which will kind of make our code more compact and readable for others, or basically they can just use my class and they don't have to worry about how I am handling the data structure inside it, or whether how the functions are even modifying it. The member functions, they have their meaning associated with, just like let's say fly, right? For a bird class, fly has a meaning associated with it. So you don't like we don't the user don't have to know, or they don't necessarily have to know how the bird is flying, but if he calls the member function fly, then the bird flies. That's the logic, right? That okay, we'll define a class. The user don't have to know whether how they are storing that, how I am storing the data, or how I am implementing the functions or member functions or methods, right? But he can use it as far like uh, as much as he can like, right? Given that he knows how the like what to do with the class, so he have a detailed kind of documentation about what are possible with that class. Just like for example, let me just switch to the yeah, just like for example the dictionary class that we have taught you, right? That dictionary or tuple class in your 8th week, that that how to handle or manipulate each entry, how to add new entry, how to remove each entry. Let's say whether I want to search entry. These are the functions that are possible on that data structure. For example, this week's tuple data structure, right? Your tuple data structure that you learned, as well as dictionaries that you have learned in the earlier weeks. So those are kind of example of classes that you already know, that you don't know how the data is stored, right? You have a representation of in your mind that okay, dictionary means it's a key colon value pair, but in the data structure, whether it is storing the data in terms of a key value or they are storing it in separate lists, we don't know, right? We have to see the code like on the Python implementation, then we will know, okay, now this is how dictionaries handle keys and values corresponding, like key one corresponding value v1, how it handles them we don't know, but okay, we can add a new key and a value, or we can remove a key value, or we can even search a key value. These things we know, right? And that makes this, what this makes is that I can use dictionary anywhere, given that I know what I can do with it, but like I don't have to worry about how the data is getting stored. This is the main concept of classes, right? So we kind of covered a bit about classes. Wait, let me just make it full screen that I can switch between. Okay, minimize this. Yeah. So for the car dealership program, I guess I have also shared you the code. So let me just show you where I am putting all the codes for the weeks, right? Just in case you want to kind of get a refresher on them. This one, right? You can just, this sheet is already shared, I guess, with you, right? You can just go to the drive link, and then here is the codes for all the weeks. Okay, up till week 7 we have it, but for week 8 I will upload it today. Week 8, this is week 8, right? So I'm keeping all the codes in the presentation folder itself. Okay, now okay, so till the last week what we have covered, we have like taught you the basic syntax of how to define a class, what are the necessary functions you are supposed to declare. Let's say for like the constructor, or let's say any arbitrary method that I am to declare, these things you already know, right? So just let me know whether you remember them or not, right? Because we will just do 2 example problems on that, and then we'll move to image processing and sentiment analysis. Okay, that is the course material. So we'll just finish uh, like classes, like like un, like up to which you should know at this point, and then we'll continue on the like image processing and sentiment analysis stuff. And so this class will show what is image processing, or how that is useful, and how that is useful in current scenario. So in terms of deep learning or all those things, how image processing is kind of relevant, and for sentiment analysis as well, how what is the crude way of doing that. So basically how like before deep learning, how we are kind of associating sentiments, negative positive sentiments from a center, or what basically a kind of brute force approach. Okay, and then how with like advances in deep learning and machine learning, how it evolves to a kind of end-to-end problem, that okay, I have some say statements, and I have some labels that okay, this is negative statement, this is positive statements, and then I can just learn a mapping from those sentences to the sentiments. But okay, before that I'll just show you ki, okay, what is the best crude way to extract out semantics, sentimental meaning of a sentence. Okay, so okay, just let's finish up the classes, because like otherwise incomplete or like fragile knowledge of something is bad. So let's just do two like example problems on that, and then we'll move to these topics. Okay. Okay, so just let me know if you remember the structure, or I will just give you a quick reminder. Do you remember the how to write classes, or what are the necessary functions? Okay, let me just remind you then. Okay, so a class is, the class keyword is there. So after class keyword, whatever you write, that is the class name. Okay, and by default all classes are subclass of the object class in Python, and everything in Python is an object. Okay, now object class which has few like few already predefined functions in it, just like init or repr or underscore underscore str. These are the kind of defined functions in Python. So whenever you type print on an object, it calls its representation function. The underscore underscore repr is getting called. So whatever string you are returning from there is getting printed basically, right? Like for example, the init class, init method, right? Init method is the initialization or constructor. So whenever you call it, create a like let's say create an instance of the class, let's say object one or o1 or o2, that init method gets called, right? And you can kind of store data in that from that init method. Let's say I want to store an array in an object, so I can just pass that array in the init method itself. That will kind of store the data in the class, right, or the instance basically. So this thing has just do a hands-on. Let's see. So today's two problems are very interesting actually. How to design a coordinate system class. So we all know coordinate system like x, y, z, right? And now I am to design a class that handles coordinate all operations of a coordinate system. So what are the operations I can add? So coordinate system basically a vector class, right? A 3D vector class. So I can define a vector, I can add two vectors, I can subtract two vectors, I can get a Euclidean distance of two vectors. These are the three right? These are the three main methods that I can apply on a vector. So we'll try to implement a vector class first, and then basically just for a reminder, a person object that okay, whenever I ask him his name, he just say me like return with hello, I am this, and it has, let's say, some basic characteristics like he can walk or he can sing, something like this. Okay. Now then we will go for image processing and sentiment analysis. Okay, and just you can you can discuss any problem you are having with the 8 weeks course material or anything you are not understanding at that point. Okay, so let's not delay it and start implementing them. Right. Okay. So first question is to implement a class. So basically it's a vector 3D class, 3D vector class. Okay. And just for a like survey guys, so do you want to show me how to plot in Python? So we can schedule it somewhere later in the how to make plots. Let's say you have some data and you want to plot it. So whether you are interested on that part, you have to plot data. Okay, you can just think and put it in the chat. I can just meanwhile I will just describe the problem. Okay, so to implement a 3D vector class, first define the members. So class name is vec3d, right? Vec3d. Now what are the member variables or parameters, you can say? Member parameters are what? X, Y, and Z, and methods, just call them member methods. Member methods. Okay. member methods, right? So how many member methods we can do? We can have addition. Two vectors can add with each other, that is vector sum, right? We can have subtraction, and we can have distance, basically distance. And let's just just for simplicity, let's just say we will use the plus operator for addition, we will use minus operator for the subtraction, and for distance we will use this operator. Okay, okay, so these are like the operations we have to define. Okay, whenever I plus two vectors, let's say v1 plus v2, what will happen, right? So I'll, in the last class you have only learned about two default functions, init and this repr, right, representation. But today we'll also learn about add, subtract, or distance. So that is this is actually r shift. Okay, so these are the new functions you're supposed to learn. So you can anyway define the add function like this, but giving this underscore add underscore will also let Python know that okay, whenever I am doing a plus, it should call this function, or whenever I am doing a minus, it should call this underscore sub function. Okay, so because these are already defined in Python, it knows ki whenever I am using this operator, what function I should call. So we'll just go with these functions that Python already know. Okay, let's just comment all of them and try defining the class vector 3D. Let's define the init function. Self, I already told you in the last class that okay, self is the default parameter of any member function, right? So you have to give the self. So we'll know what self means today. Okay, and then x, first parameter, so what is the x coordinate, what is the y coordinate, and what is the z coordinate, right? Now colon, and now I have to store them as a part of that self, right? So whatever instance you are having, let's say v1, so v1 dot x, that in terms of v1, what is it? It is self dot x, right? So that's why this class is a kind of generic layout of a instance. So whenever I am creating an instance v1, this self will be replaced with that instance. Okay, so we'll see self dot x is equal to x, self dot y is equal to y, self dot z is equal to z. Okay, now let's do the representation function. So what we should return, we should return a string that represents my vector, right? So let's assume that it's returning this kind of a string, x comma y comma z. Okay, dot format self dot x comma self dot y comma self dot z. So let's just test. Until now, what behaviors we should have? We should store the data in XYZ, and we should be able to see the data in terms of representation, right? Not like that underscore main dot has something. This type of garbage should not get printed. Okay. So vector 3D, I want a vector of 1 1 2. Okay, it's getting printed in my notation, right? And I have the data as well. So self.x is 1, self.y is 1, self.z is 2. So the data is also getting stored in v1. Let's say v1 equal to, and now I can see v1.x it's 1, v1.y it's 1, v1.z it's 2, right? So at this point, what we have the data stored in the class or in the instance, and then we are having a good representation of it. Now let's, and if I, let's say, create another vector vec 3d 232 231. Now if I just add them, a v1 plus v2, see what happened. It says support unsupported operand plus for vector 3d. So there is no supported operand, like the plus operator is not supported by the class. Why is so? Because I have not implemented what would happen whenever I call plus. You get it, right? So I have to define it. What should happen whenever I do a plus? So the associated function is underscore underscore add underscore underscore self comma other. So what is it? This self is this self is actually the left operator v1. Okay, and this other is the right operator. So if I add, v1 will be passed as a self and v2 will be passed as other. Get it? So this is actually v1 and this is actually v2. So what would be the output? So if I add a vector of 1 1 2 plus 2 3 1, so what would be the output vector? It should be element wise sum, right? So it's like 3 comma 4 comma 3. This should be the output, right? So what is happening actually? See, it's so this vector x is getting summed with this vector x. That's the x of the new vector. Similarly for y and z. So you can just return another vector 3D, which is the new vector, right? Which has self dot x plus self dot other dot x as its x parameter. This is passed as its x parameter here. Now second self dot y plus self dot other dot y. So both y parameters are getting added and passed as the new y parameter of the new vector or resultant vector. And lastly self dot z plus other dot z. So the resulting vector would be sum of x, sum of y and sum of z of v1 and v2. See, this v1 is passed in self, v2 is passed in other. I can just print them here if you like. So you can just verify. Print self, print other, right? So I can just have all them. Yeah, see, first self is printed, so v1 is printed, second v2 is printed, and the output vector I am getting v3 is equal to v3 is equal to, I can see v3 is equal to 343. Okay, so you get the implementation, right? How I am defining the add operator on a object, or let's say on a class. Okay, this is exactly how, let's say, the all the like adding two lists. So you can just do this, right? 1 2 3 plus 2 3 4, and you get a new list. You get a new list having all the elements. This is how it is implemented in Python. This is how in list class the add operator is implemented. So the first list is passed as the self, passed as the self parameter, and the second list is passed as the other parameter, and then the combined list is actually sum of all the elements, right? So basically all the elements, concatenation of all the elements. Okay, I hope it's clear now. It's more clearer at this point, right? How this operation is implemented. Similarly, you see, whenever I am giving a minus here, it says, okay, it's not defined. So exactly same. Let's say if I want to do a minus on v2, v1, v2, it will also same with this. Okay, for the vector 3D class, this minor operator is unsupported, right? Similarly, see, the list also says the same error, right? Unsupported operand type is for minus, list and list. So you cannot do a minus operator on a list and a list. Now, why that is so? Because you see, I have not defined the subtract. What I should do on a minus call, I have not defined it in our class. In Python, list, there is no valid implementation of list minus. So plus defines concatenation. So you can just get them concatenated with each other, right? But minus, it doesn't have any semantic meaning, right? So you cannot minus two lists. So that's why it's not defined. That's why you cannot minus them. Okay, But for vector, I can easily define a minus, that is element wise minus, so I can just copy the exact same code as plus. Just remove these print statements, you get the idea, right? Yeah, and then just replace all these plus signs with minus. Okay, so this gives me sub. So the sub means subtract. Okay, so I can now add v3. So v1 plus v2, let's just not store them. v1 plus v2 gives you this, and now v1 minus v2. Earlier it was showing it's not supported. If I do it now, it says me okay, now the difference vector is -1 -2 1, which is true, right? So this is -1 -2 1. Okay, you get it, right? Now the last question, so how to define this? So up until here we are done. So finally the distance operators, I can also see what is the Euclidean distance of two vectors. So I already told you the function is r shift self comma other. So it will be called whenever I do this v1 v2. See, currently it's not implemented, that's why it shows it's unsupported, but by implementing this function I can, so just let's this print self comma other first. Okay, it's not return anything, just print self comma other and see what. Okay, so whenever I call this, the v1 and v2 gets printed, but it should be something like this, right? It's Euclidean norm. So Euclidean norm is what? x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square root over, right? The square root of that whole expression. So we can, instead of doing this, we can just write that. So self dot x is x1, other dot y, sorry, x is y, x1 minus x2 has like it's already this one. We can just do a square. Let's just copy them and paste them. Copy pasted. So now in the second segment it will be y. So y1 minus y2, and the last one is z. So z1 minus z2. And now for the whole thing, to do a square like root over computation, you can just to the power it with 0.5. That's to the power half, which means the same as square root, right? So this is the, so distance is a scalar value, right? So this is the distance scalar value return. So this will return a scalar value. Okay, what is the distance of 2 point v1 v2, and now we have okay, these 2 points are 2.449 unit apart from each other. Okay, now you can also define what is the angle between two vectors, right? These things you can, like, if you are implementing something that requires like frequent computation of angles between 2 points. Let's say for example, if you are, let's say, um, so for example, if you are tracking an object, right, from a fixed point, so you are also supposed to know what like how much distance it is there, and like how much angle it is making. So it's like polar and polar coordinates, right? Like what distance it is from the origin, and how much angle it is making with the x-axis, right? So to have a polar coordinate system, so in that case you are supposed to compute angles multiple times. You can just implement it in the class itself. Okay, if I use, let's say, ang operator, I can just define a custom function ang self comma other, which will give me the angle of two vectors. Yeah, also you can define the dot product, cross products, and all those things. right? The vectors can be dot product or they can be cross product, right? So angle, how we can compute angle? Can anyone just unmute and say what is the logic of computing angle between two functions, two vectors? It's like basic 12th standard
Tan
math.
inverse x by x
Yeah,
plus
tan inverse you can always
b
do, but
square.
we are but so tan to have tan inverse you have to compute the, like it has to be a right angular triangle, right? And also you have to know the, like the lambda and the bhumi. So I get the width. Uh, triangle, right angle triangle, right? So to compute tan inverse of a by b, it has to have a right angle, right? Otherwise you cannot do it. See this figure. So do here, right? To compute this angle c, so you this triangle should be right angular, but it may happen that the triangle that is being produced by two vectors are not a right angle triangle, right? Do you want to try again? I can give you a hint. It's the dot product. So you remember what is dot product in closed form? So dot product is what? A dot B is equal to mod A mod B cos theta, right? So you can just do a reverse. Ki A dot B by mod A mod B, you can just take a cos inverse of that. That would give me theta, right? You get it, right? See, let me just show you what I am told. Uh, dot product between vectors. See this, it actually creates a projection which is a right angular triangle, right? And then computes the theta from that projection, and then this thing a cos theta and this b. So you get the formula as this. See here, a dot b is equal to mod a mod b cos theta, and theta is the angle between the two vectors, right? So now you can just do a cos inverse. So let's just define dot product first, and then we'll do the angle. Now dot product is what? It's element wise multiplication, right? So def dot, we can implement it as a multiplication, MEL. Okay. So whenever I multiply V1 multiply V2, it will create a dot product. And I'm not talking about cross product at this point. Okay. Okay. Self dot other, it should return a vector 3D, and the elements should be, just copy from the, and elements should be multiplied, right? This is dot product. Now multiplied and summed. Right. So yeah, they should be multiplied and summed together. That would be giving you a dot product. It's a scalar value, right? So now angle mod we have to also define. So how I can compute modulus of function, modulus of a vector x square plus y square plus z square root over of it, right? So just compute mod. Oh, sorry. See, I can always compute all those things in the angle function, but it gives me less usability, right? Let's say I only want to compute dot product in a later point of time. Then if I define all those things within that angle function, it reduces the modularity of the code. So I have to rewrite that code again. instead if what I can do, I can kind of like make small pieces of code kind of segmented it, right? Like it's the dot product needs modulus and the let's say angle computation needs modulus and the dot products. I will not define them within the angle computation. I'll define them as a separate function so that I can use them in the kind of later scenarios, right? Okay, so now mod only works on one vector. So and what will be the what is mod? So mod is return, it's a scalar self dot x, sorry, self dot x square plus self dot y square plus self dot z square to the power 0.5. So root over of x square plus y square plus z square. Okay, now let's not name this underscore mod it because it's our own function, so you can just name it mod. Okay, it's not defined in Python, or actually ABS function is defined. So let's just see, I guess ABS is there, ABS absolute. Okay, so let's just see uh, whether I can call ABS and it calls that underscore ABS of v1. Oh yeah, so ABS, this is absolute function in Python, ABS, right? So in ABS I can have that mod function defined. So in angle computation, what I'll do, so I need a dot b by a dot b by mod a mod b, right? So self dot underscore multiply, or I can just do this. I should not use that because it already, by using the star operator I can directly call this. Sorry, I can directly call this. I can just do self star other. So it computes v1 times v2, v1 dot v2 divided by absolute of v1 times absolute of v2. So abs self times abs other, right? So this will give me a scalar value and these two will be separate scalar values multiplied with each other, and now I have to use a cosine inverse. So cos inverse of this value, right? So cos inverse, how I can compute cos inverse? I can use the math library or I can use the numpy library as well. Okay, math dot arc cos. Sorry, not arc cos. Yeah, this is the arc cos function. Okay, a cosine or inverse cosine of a number a. Arc cosine, that's the function a cos. Okay, I can just call this function on the whole thing, return it, and it gives me values in terms of radians. So it gives me theta value in terms of radian. Now if I have to convert it to theta, right? So I can just define a function, convert to theta, sorry, convert to degree, self, and the radian value I will give. So I have to multiply it with 180 by pi, right? So return rad times 180 divided by pi. Now math.py I can use math.py. Yeah, and basically call that self.convert to degree function over that arc sign, arc cos. Okay, let's just put this whole thing over here before import. Now let's see. Absolute I can compute, positive plus I can compute, minus I can compute, I can get the Euclidean distance as well. Okay, okay, and lastly I can also have angle between V1 and V2. Okay, what happened? Unsevered operand for star, int and vector 3D. Where? Sorry. Here I misplaced that. It should be plus here. Oh, I misplaced it everywhere. So dot y. Okay, dot x, cell dot y, cell dot. Now it's fine. Yeah. So the angle between the two vectors v1 and v2 is 40 degree. Okay. Now, uh, so do you want to see these vectors? Just tell me, do you want to see these vectors, how I can plot these vectors in Python? Okay, this is vector 1 and this is vector 2. And you can see, okay, this is
Yes,
the
sir.
angle. Okay, okay, now see. So this should not be part of your course, I guess. It's a bit advanced topic. Later on in the data analytics course, if you follow, like if you enroll for a data analytics course, you will learn these things. Uh, let's see. Yes, never bad to learn some things that is okay. PLT plot. Now let's just have 2D vectors, okay, for now. So I'll keep z axis as 0. Z axis will be 0. Okay. So now it becomes 2D. I don't have to consider the third dimension. Yeah. So their angle is 11 degrees. So let's just increase it to some bit 6. Their angle is 18 degree. Let's make it 0. Still 26 degree. Wait. Yeah. Their angle is now 59 degree. Fine. Now you can plot it. So x is 0. The first vector v1 dot x, y is 0, v1 dot x. And the maximum value I have is 10, right? So, oh, sorry, this should be 1. Yeah, it prints a line. You see this vector. It's actually, let's just increase the line width. You can see it. Yeah, this is the vector. This blue line. I can just change its. It's only at the y direction. That's why it's showing like that. Okay. Uh, y limit. Just keep them 5. Yeah, this is the vector, this blue line. Just tilt it a bit so that it looks good. Yeah, this is the vector v1. Okay, let's just label it, label v1 and put the legend plt dot legend. Yeah, so v1, this blue one is v1, and now let's just print v2. Okay, so v2 would be, yeah, and this is v2, and it's actually going out of the frame. So to see what is the maximum value, thus, right? So you can just limit the x and y axis to be 10 10, then we have the whole. Yeah, then also you don't have the whole, so just increase 12 12. So this is the two vectors we have currently we have in the system. These are the, this is v1 and this is v2, and the angle between them is 32 degree. It's almost 32 degree, right? Okay, let's just cross check by implementing a 90-degree vectors, right? So we just have two 90-degree vectors and then check whether their angle comes as 90 degree. Okay, so what is 290 degree? I can have v as a y vector, so 0 comma 10, right? And then v2 to be 10 comma 0. So it's a y vector and an x vector. They are um, kind of 90-degree vectors, right? 90 degree. Now in terms of the figure, you see their angle is 90 degree. So this is v1, this is v2. Their angle is 90 degree. You already know x and y axis, and in computed we have also computed 90-degree angle between themselves, right? Now I can do 45-degree as well. So 45-degree, let's just add v1 to be a 45-degree vector from x axis. Okay, so it will be 5 5. Let's say 5 5 is a 45-degree, right? Yeah, their angle is 45-degree, and in terms of image it looks like this. So this is v1 and this is v2. Their angle is 45-degree. We know. Okay. Okay, so okay, the vector class is almost good. So now you can like do anything with it. So let's say I can define a trajectory of an object, let's say a trajectory of a ball in terms of vectors. Okay, so how I can do that? So how I can do that? Let's say I am say ball is there, xyz is a location of a ball, and then it has a forward um, it has a constant velocity, let's say, okay, on at a particular direction. Then it should only go along that direction, right? So what will be the trajectory? It should only increase one particular axis, right? So we can define that type of movements. Let's say that type of movement. Let's say the initial vector v is vector 3D. So this is how you let's say you want to design a physics simulator, and this is how you define a vector 3D class, and you can just apply all types of physical properties, like whatever Newtonian physics you know, you can just implement it within that vector, so that you can have, let's say, damping effect whenever a particular vector, let's say, hits a wall or something, it has some rebounding effect. These type of things you can also implement in kind of in a part of the class. Okay, so you can also associate materials of a function, materials of a vector, right? So whether that vector is a, like, let's say a kind of bowling ball, it is a hard object, right? So the vector associated with that bowling ball would have another property as material which is hard. So based on that, it will kind of show rebounding or kind of bouncing effect in terms in different surfaces. right? So these things you can also implement if you are implementing like like in terms of objects, if you are implementing vector 3D. Okay, okay, let's just not get deep into it, so just waste plenty of our time. We just go with the person class. Now I guess you enjoyed the visualization, right? Later on, if time permits, we can also show you how to visualize, let's say, some other things, like let's say lines or mesh, or let's say scatter plots, right? Those type of things on the end weeks, let's say. Okay. Oh, let's not delete them. Let's just keep them here. The delete cells. Okay. Okay. Now, where is the? Sorry. Now, coordinate system we completed it. Now let's go for the person object. See here, I told you that we can also play sounds from Python, right? So let's say if you call a member function, it let's say if it's a cat class, it can mew, right? So let's just download some hello web files. Okay, I will just let our object play a sound whenever I, like, let's say, ask him to say hello, right? So let's just get this file. I can download it. Yeah. Okay. So this is a web file, right? Hopefully. And so it's where nptel resources, and the thing is hello, hello. Yeah, it's in web file. So I can just now play, see how play a web file in Python. Yeah, so you have to use the library obviously, and the library is uh, yeah, this play sound library. So you see these libraries are like, you can have multiple libraries doing the same thing, so it's better to not remember like these things. Okay, it's better. So play sound is not there, I can just install it like this, pip install play sound. So there are so many libraries in Python, so it's never a good practice to remember all of them. So you just know what is possible, what is not possible, and like whenever you want to implement something, you know, okay, this is possible, I can just search a relative. And then Google and ChatGPT is so much efficient nowadays. So you can, so if you know what is possible in Python, you can just do a quick search and get, okay, which library will help me to do it. Okay, it's never a good practice to memorize these things. So only if you are not giving a exam. So whenever you are giving an exam, you have to know the, you have to remember some things, right? So you just don't get it, but like don't get it in wrong way. So you have to remember something for your exam, but for your like coding career or anything, so it's not necessary to remember the library names and all. Okay. So what happened? Uh, no such file directory. Okay, where does it? Okay, what happened? File not found. So this file is not getting found. See how this is how you are, how you should debug the code as well. So we are getting file not found error. Okay, no such file or directory in this path. We'll just do a search and see whatever results are getting. Okay. Okay, looks like we don't have its installation in the proper directory. Source miniconda being debate. What was the play sound? Let's see whether it works this time or not. Data is relying on Python 2 subprocesses. Oh, if you want to, okay, please use Python 3 install PyObject-C if you want to play sound to run more efficiently. Okay, so it uses Python 2 for some reason. We'll just see whether I can play background sound in Python 3. Okay, let's just try this library once. Just copy the code, paste it here. The path would be /resources / hello. Yeah, yeah, it plays, right? Okay, fine. So we have the web object, and whenever we want to play the audio, I just need to return these two, right? Something like this. And let's just define our human class. So the next question is define a human class that can say hello, bye, hello, bye, and his name. Okay. So what is the data structure? So class human. So parameters. So what are the parameters? I'm talking about name. Only name, right? I'm not. Let's say name and age. Age. Okay. So name and age. So name, I have the parameter name and I have the parameter age with me. And then member methods. What are the member methods I want to build? Hello. So whenever I call hello, he should hello back to me. Let's say whenever I call bye, it should bye back to me. And whenever uh, let's say uh, greetings, right? So whenever I play greeting, right, it should say this: hello, my name is whatever name, or not whatever. Let's define the name to be only John, right? And my age is 23, something like this, because we will download these two, right? Or basically we will download, or we can also use a text to speech API. So let's just see whether it is working using iGame. What? No, so now see. So this is how you save the data, right? And we can just use the previous code, this one, to play. I can just do start resources, not welcome. mp3. Let's see. Okay, GTT's module is not there. You can just install it, see what it is called. Okay, this is how you install it. Okay, this is the Google's text to speech API. Oh, sorry. Oh, it was already there, I guess. What happened? We started there. Okay. It expects in web file. Save as a web. Okay. Let's see what is getting saved there. Wait. Resource- Resources. Okay, we have these two files. What are they? Are they getting played open with time? Okay. They're fine. Okay. Okay, so what is happening? So we can write them as web files, right? But we cannot. We cannot play them. Why? File doesn't start with RIF ID. It's just starting. Make search it. Okay. Fill to FNOF file due to file doesn't exist with this. Or what we can do, see, because so it's actually an encoding error. So it expects this tag to be there at the beginning of the file, so that it can know, okay, this is the beginning of the file. Okay, but somehow whenever this my object writes it, does it has any encoding tokenizer and all those things? Okay, no. uh, okay, so color here. Okay, so right into numpy with librosa. So what we have to do, hmm, mm, mm, mm. My object are saved. After that, what I can do, I can just, yeah, I can just do this. Let's see whether it works or not. Okay, so quick install. Wait. Good. So now it is working. So see what I have done. So at this point, uh, this is the text I want to print it in terms, or I want to kind of do a text to speech, right? So what I am doing, I am creating the WAV file first from the Google text to speech API, and then because it has some tagging issue, some tags are not there, that's why I cannot read it for the playing part. So what I am doing, I just read it with Librosa and rewrite it, okay, with the tag. So whenever Librosa writes it or the sound file writes it, it actually add that tag whichever is missing. Okay, now I can play it. Okay, so see, now I can write the class. I know how to like kind of use the Google Translate speech to text, sorry, basically text to speech. So I can ask anything to my human class and he'll basically answer. So basically, let's say I define this to be hello, and this to be name, and this to be age. Okay, bye, bye. Let's say see you. Okay, so these are the functions I want to define. So let's just define our class now. Class human. In the constructor, I just define its name and age. Okay, so self dot name to be name, self dot age to be age, whatever age I pass, and now the functions. Hello. So what are the functions? Hello, then bye, and lastly greetings. Greetings, right? Now I have to also make a helper function for this, for the whole speech to text, right? Now let's define a helper function. Text to speech. Okay. second speech cell, and I will pass the text to speech, and what will it will do, it will basically save the corresponding uh, the temp file, okay, the converted text, the speech file. It will save the text speech file. So let's just save the speech file. Now here I can have a speak function as well. So I'm kind of like compartmentalizing. So I'm basically compartmentalizing separate segments of code. So based on their like, so based on the unit task, right? So text to speech is a unit task. So there is no subdivision among it. Speak is a unit task. Hello is kind of a, so first I have to convert it to speech and then I have to speak, right? So this is kind of a compound task. Okay, so we have to define these two, then I can like define any of the three compound tasks, right? Here this class is speak the speech, okay, and now these are the compound tasks. So how I can define them? So let's just put all the libraries together first, uh, here, right? Okay, sound, yeah, these things I need. uh, Language, let's just fix it to en. uh, my text will see. So this function saves the speech, okay. So the speech saving part is up to here. So just copy paste it from there to here, format it, okay. So fine. So it let's say it saves to tmp.web, okay, or just name it differently, tmp gtts, the like untagged audio sample, and then after that we read it gmp gtts and write it as gmp speech, okay. So now I have the, so or not, let's say only speech.web, okay. So now I have the speech saved at resources speech.web, whatever text I pass. So let's say text to be text. Now speak what I need these three, and I don't need these things for now, okay. So now the speech is saved at resources speech.web and it plays it. Whenever I say speak, it kind of plays the speech web. So before speech I have to run the speech.text with the text input so that the corresponding speech gets saved, right? So now it's very easy to have these three functions. So for hello it is defined that, okay, text, do a self dot text to speech on a hello string, and then self dot, sorry, speak. Similarly for by, I can just replace it by see you, right? And lastly for the greetings part, whenever I greet him, he just say, or I can just use this function first, and it will be actually waste of resources. So first time, so I can do hello, something like this, like hello, I am nice to meet you, sorry, my name is this, nice to meet you, I am years old, okay. and for these variables I can just do a string formatting, self dot name, self dot age. Okay, now I can always call the hello first and then do all those things, but you see, whenever I am calling the speech to text API, it actually like queries the Google servers, right? So it's better to have the whole string as one, because it will kind of trigger only one query. Whereas if I just do hello first and then the rest of the query, I can always do this, right? Self dot hello and then kind of remove hello from here, but it will trigger two network queries, two queries to the Google servers. So it will basically waste resources. So one, you can rather do or rather call the hello or put the hello inside the whole greeting string itself. Just so a better or an efficient way would be to just add hello in the greeting string itself instead of calling it separately. Okay, now let's just see what happens. Okay, so now I have a human class, let's say h1 human. Let's just pick any of your names. Okay, let's pick Vikram. Okay, so Vikram, I'm using your name for this. Okay, can you tell me your age? Hello, anyone want to volunteer for this? Guys, okay, leave it. Let's just put my name. Okay, right. So my name is Prasanjit and my age is around 25. H1. So now okay, we forgot to do the representation class. Sorry, representation function REPR. Self, I should return H, sorry, H human, then its name and age. Name is equal to age is equal to, and then do just format self dot name, self dot age. Yeah. So this is how the human class is printed now, and I can just try to call all the functions. Oh, we can just select someone else's bias, I guess. Right. Uh, this TLD, Google GTTS, let's see. TLD is uh, how we can select the bias. Which, okay, wait. Now how I can change the voice of that audio? Let's search GTTS. Change the default voice. Used for the accent. This is for the accent. Okay. search what is the these options are there. So supported voices and languages. Standard, we can use any standard male voice. Let's say this one. This is Arabic. Okay, yeah, all of them are Arabic. Fine. Hey, what happened? This TLD parameter, it changes the audio. Okay. Okay, what happened? Failed to connect to words is not reachable. Okay, whatever is reachable would work. .com. Okay. Now here, yeah, this is the default, right? Change voice. Okay. What is the I can change the speaker here. Wait. Already settings. Okay, just leave it. So I have to just do some search on this voice name. Uh, AU. No, it's not reachable. Let's just leave it. Okay, just name something else. Lisa, so that it matches with the voice. Okay. Hey, what happened? Restart the kernel. Oh, sorry. To remove this parameter. SA is not defined. Why? Oh, here. Yeah. So now it says hello h1 dot by, right, and h1 dot greetings. No, you get my point, right? So you can also define many other similar functions, right? So you can also define, let's say, so you can always have a graphical GUI as well, right? Based on that, you can also define a human object and basically ask him to, let's say, walk around the screen, something like this. Okay, these are your, let's say, for your homework. So there are these libraries like pygame and all, where you can define these type of behaviors for a human class. Okay. So anything, so any confusion till now?
Uh, am I audible?
Yeah, you are audible.
Yeah. Like, I teach someone then, like how to do for customized voice. It's
So
possible.
your voice is
Is it
breaking.
only
So
those?
so uh, so I guess it's better
Yeah.
if you can write it in the chat. So I guess there is some network issue on your side. So your voice is breaking a bit. So I cannot understand the whole context. So you can just write it in the chat if you want. Okay.
Okay.
I'm just monitoring the chat. So just write it. I will answer it. Anybody else? Okay, we'll come back to the chat and see what Deepak has to say. I didn't get what you were saying. Maybe there is a network issue on his side. Okay, now I guess someone is writing. So guys, how your assignments are going? So you can solve some like all the assignments, or you're facing some issues? And did that problem you're facing with one assignment, I guess it was on week 4 or 5, that got resolved or not? That some of the test cases, even though it's ran on your system, it gets an error on the server. Okay. Okay. So what we did, we also created a Python like parcel class. Right now let's go for image processing and sentiment analysis. So okay, let me just go and drink some water first. Okay, I'm just returning back.
Will we have any sessions for data also, like how to deal with data using Python? Hello?
Yeah, I can hear you.
Yeah, I was saying, will we have any sessions like how we use data in Python?
Data by what do you mean by data? I guess, can you just explain? So what do you what do you want to see in terms of that session?
Like today's session, we were seeing some graphs and all.
Okay.
So
So yeah,
that
that
way,
can be like that can be a session. Obviously, say that let's say how we can plot different type of graphs on a data and kind of draw observations from them, right?
Yeah.
And how, yeah, okay. So I'll organize like kind of I have to like structure that session. So what type of observations I have to show you, so those things I will decide, and kind of maybe within next 2 weeks I'll have that session. Okay, there will be
Okay.
kind of how to get observations from data and how to plot them, and which type of data I should use, which type of plot. Okay, but I
Okay.
guess this plotting is not like not as a part of your this course, right? In the main course content, is matplotlib is
Yeah.
covered? I have to check. I have to check it. Let me just see whether matplotlib is covered in the course or not. Maybe in the later weeks it's covered. Uh, mm, no, it's not opening. Okay, I will see. Okay, anyway, we can obviously conduct a class on that. Okay, that how to visualize data and how to draw inferences from that. Okay, now let's just move to the next segment. Okay, it's already open, I guess. This one.
The sentiment analysis that was given in the video, that I like I couldn't perform that. I don't know.
Yeah. Okay, so I also like, so see they in this case I guess they have used some libraries to do a sentiment analysis. Okay, negative, positive, or neutral, but we will kind of like kind of see the problem in terms of incremental steps. Okay, so what we can do, so the basic rudimentary steps we can perform, and then how it moves to like today's sentiment analyzers like neural networks and all. So we'll not discuss neural network, but we'll give you a flavor that okay, this is how it is done. Okay, maybe apply some simple models on that. Okay. So NLP, it's fine. 10 data compression and all, bit 12 on calculator. No. So in the actual course material, I guess it's the plotting and data visualization part is not covered. Okay, so for your understanding, we'll just take a class on that, how to visualize data. Okay, now for the
Okay.
image processing and sentiment analysis part, let's say, so what is image processing first of all, and how it is useful, right? So let's just take an image. um, let's just have this site. Okay, and upload any picture, so image. Let's just take this image. Okay, this is a standard image in copy image, no, save image as resources, browse, it's on the web, resources, after web. Okay, now we have that image. Okay, now what is image processing is means, let's say this is a ground truth image. Okay, and now I can apply different type of transformations to it. So for example, I can flip the image, right? That would also give me the same image but in a flipped version, right? Similarly, I can increase, let's say, the brightness. This also give, so the semantic meaning or the meaning of the image doesn't change. Whenever I am applying some image processing technique, the meaning of the image should not get distorted. For example, if it is an image of a cat, after the transformation, it should not become a dog. Okay, this is ground like rule zero of image processing. So the image processing should not alter the meaning of the image. Okay, yeah. So even if I increase the brightness, you see at this point the meaning of the image is changed, right? So I should not so now it's a like white blank screen. So I should not add so much brightness that it basically removes all the data from the image and basically makes it a opaque or blank screen, right? Or let's say this is one extreme. I can have maximum brightness, it will alter the meaning of the image. Similarly, if I, okay, it's not reversible. Okay, so okay, to re-upload the image, I guess, refresh, re-upload the image. Yeah, now I should not also do this type of things, right? So till now the meaning is like somewhat untouched. Yeah, untouched, fine. Now it becomes kind of going, yeah, now it doesn't mean anything. Huh. So now it doesn't mean anything, right? So the semantic meaning has changed. Now if I increase it, you see, because so this site actually applies the transformation and doesn't undo it. So when I basically increase the brightness, it doesn't undo the previous like like whatever I have applied brightness to it, right? It adds the brightness on top of it so that the data gets modified. Okay, so I have to re-upload the image again. Fine. Now I have the original image. So we have to do some image processing which will serve me some purpose but doesn't change the semantic meaning of the image. For example, this contrast would, so these type of, these are actually how you do image processing. So let's say you are so one of my colleagues was working on this project on, so he was a colleague from CMERI Durgapur. So he was working on identifying insects from like leaf tops. Okay, so when let's say you are producing a crop, right, and then some insects they damage the crop, and you have an UAV which can take images from all like let's say multiple patches of the land, and from that images you want to identify whether there is an infestation of like these insects or not. Okay, so this was their problem. So what they did, they captured the raw images from the UAV or the drone, right? They captured the raw images and they saw that okay, the brightness levels are so low in terms of and so the insects are also green, right? So they are inseparable at some stage. So what they do, they basically increase the contrast before processing the image further. Okay, otherwise these differences between the insect, the green colored insects and the let's say little bit uh, dark green color leaf is kind of not noticeable from the like naked eye. So what they did, they increase the contrast. So the lowest and the highest point they get further separated, so the insect is not clearly visible. So this is how, like, this is when you apply this kind of transformations. Okay, you get a kind of clear idea where we increase contrast. For example, when there are lighting condition is very low, right? So most of the picture is dark, and you want to kind of uh, have all the images within a kind of fixed brightness level. Then you increase the brightness level of all the other darkened images. That's how you kind of ensure that all the images that you are training with, they have the similar range of brightness levels. So some images are not too dark, or some images are not too white, too exposed to brightness. Okay, so same, let's say saturation increases the let's say blue. So if there is Saturation you already know that it basically increase whichever color is prominent, it will increase its intensity. Okay. See, the wherever the red is prominent, it increases the percentage of red, and when blue is prominent, it increases the percentage of blue. Right. Similarly, you see these type of effects also vintage, right? It converts it to a black and white image. Okay. So now let's just refresh and upload the like image 0 again, and then see what each of these effects do. Lumo gives you, it kind of gives you a fixed contrast ratio, right? So basically it gives you a mixture of contrast and saturation, right? So these are some predefined effects you can do with all these filters. Okay, for example, let's see nostalgia. It should be something with a like black and white theme, right? Yeah, yeah. See, it's a black and white, but little bit of color too. So almost grayish, but not that much. So some color is there, but it's mostly grayish. So these are basically some effects you can do with changing brightness, contrast, saturation, and vibration. Vibrance. How vibrant the image is. Okay. I remove the filter. Let's say cross process. So this is some another filter you want to apply. It would work. Okay. Similarly, in Python also you can have all these filters. Okay. So based on the use case, you can apply some filters or not. So for example, if I want to detect only the edges of a let's say human being, right? So let's say my downstream task is to identify whether in front of the camera there is a human or not. That's the task. So whether there is a human or not. Okay. So in that case, like processing all the pixels is not necessary. I can just only process the edges. If it so basically if it matches a human like shape, it's a human, right? So human edge detection, yeah, something like this. So whenever there is a human in front of an camera, so there will be this kind of an edged image, right? So I can just use the Sobel filter, or let's say the Laplace filter. These are different type of filters. You can just see them. Okay, it's a part of a paper. Wait, we just zoom it. Open the image in new tab. Yeah, see this. So if this is an original image, after applying this type of different edge detection kernels, so these are known as kernels. So what happened? A fixed kernel or fixed matrix gets convoluted over the image. Convoluted means that matrix gets multiplied in different segments of the image. Okay, we'll say what convolution means later on. So original image is this, and the transformed image or processed images are kind of only the edges, and if these edges constructs a human like structure, then it's a human, right? So to detect whether there is a human present in front of a camera, you just need to process it in terms of edges. Okay, you don't have to like kind of increase the brightness, decrease these transformations are not necessary, right? And what happens actually, let's see whether I can find it. Convolution demo. It's a sorry, it's a 2D image, 2D convolution demo. Yeah, this one. Yeah, see, I can upload input image, upload image. Yeah, see, I can just paste this in the chat also. Okay, also paste it in the slides. See, here you can just see whether so these are kernels. I can upload the same image. Yeah. Now it actually, see, I can just read it in maximum 200 by 200 pixel. So it reads the image in 200 by 200 pixel. Okay. So this is what is the input image looks like. And now my filter is this. So or the kernel is this 0, -1, 0, -1, 5. This is my kernel. So whenever I apply it, see, apply, for example, identity means it doesn't change anything, it's the same thing. So it doesn't, so what happens, this kernel gets multiplied over all the pixels shifted by one, and so it shifts one by right and one by bottom. So it basically moves through all the image and produces the output image. Okay, now sharpen. See, it sharp, so the matrix looks like this, and it sharps all the edges. See, all the edges are getting sharpened, right? Now any other kernel, box blur, you see it blurs the image. So this is exactly what happens for like for the OpenCV library that you are taught in the course material. So these are the kernels you have to define, and then the application is very simple. So I can just show you one application in Python just by manually sliding through it. Okay, box blur, Gaussian blur. Now apply Gaussian blur. You cannot differentiate it directly. Let's say unsharp masking. Okay, unsharp masking. Anyway, you cannot differentiate it from any other. Okay, custom. Let's just write the Sobel filter. Sobel filter, which is the edge detection filter. Okay, Sobel operator. So I want to detect all the edges in x direction. So my filter would look like this: -1, -2, -1, 0, 0, 0, 1, 2, 1. All the edges in x direction. So let's just see: -1, -2, 1. I have -1. Sorry, minus. I cannot do minus. Wait, custom. Wait, custom. -1, minus -2, -1. So how much we have got? -1, -2, -1, 0, 0, 0, 1, 2, 1. This one is 0. This one should be 0. See the meanwhile effect. 0, 0, 0, and then here I have what? Sorry, 1. Here I have 2, and here I have 1. Right, so it gives me, or wait, let me apply custom. Does change anything? It doesn't. Okay, wait, we just get some other image. Mm. Mm. Just, no, okay. Let's just use this image. Save image as image 2, upload image 2. Yeah, and then you get the apply custom. Nope. Okay, anyway, randomize it. Let's randomize it. So this type of effect we are supposed to get. Okay, so this type of edge detection only on the x direction. Okay, maybe the sober edge detection module will see anyway. Okay. So these type of effects we are supposed to see. See this is the kernel matrix minus 1.6, 0.9, minus 2, and this if I convolve this with the image, I give this type of output. So sober filter, what it does, it gives me output like this. So from an image, it gives me all the edges. Okay. I got the thing. See whether I can go back. I cannot go back, right? So the problem was this background was white, right? The background was white and the edges were also white. So that's why we cannot see them. If I just save it, it will be visible. Wait, just do it again. -1, -2, -1, 0, 0. See the changes in the image. Meanwhile, 0, 1, 2, 1. Okay. Now this is the sober filter. Apply custom and just save it. Save the image and open it here. Oh, oh, it still doesn't detect the images. Okay, this I guess we have to increase this value to 1.4. Okay. So this is all the edges in terms of x. 13. If I increase this 20, no 2. Yeah. So yeah, this type of image processing you are supposed to do. Okay, so for a practical use case, let's say this is an image of a kind of some mechanical device. Okay, and the edge detectors works like this. The Sobel filter, if you apply the Sobel filter on x direction as well as y direction, so you will get all the edges from x and all the edges from y, and you see similar outputs you can get from these two. Sobel operator on this image. This is a standard image. Okay, so where is the other? Yeah, so this is a good, this is a good site you can play with to see all the filters you want to apply, and this playground is also very good. Okay, so here, paste it here, these two. Okay, and you can apply all those things in OpenCV. So OpenCV has a good amount of support for all those things. Let me just show you where OpenCV. Oh, so OpenCV also has C backends. Okay, so only see the Python backends. Okay. See image processing in OpenCV, these kind of things. So changing color spaces. So color spaces are something else. So you by default we read RGBA color space, but for many applications there can be HSV color space, or there is this Y something CMY color space as well. So there's these things like represents RGB in different type of formats. Okay, so you can kind of switch between color spaces with OpenCV as well. So let's say color spaces. How many color spaces are there? You see. So these are all the color spaces. So I can show you a more appropriate tip, so that is more visible. That was good enough, I guess. Just open it in a new tab. Oh, too small. So see, by this image, what I meant is the RGB color space only covers this is the whole gamut of all possible colors, right? The RGB color only covers this yellow triangle. So if you want to represent some color that is beyond this yellow triangle, you have to represent it in some other form. Okay, this RGBA, this so sRGB, see sRGB is only this triangle, this black triangle. Okay, whereas this pro photo RGB, this color space is kind of covering the whole gamut even more, right, from Adobe RGB 1998. So these are all different color spaces um, you can kind of change between. Okay, so so some colors are can be presented in, let's say, RGBA, but sometimes this RGB is not a good fit for some colors you want to represent. Okay, for example, a color here, it cannot be represented in terms of an RGB uh, color. Okay, so you have to represent it with something that supports that color. For example, CMYK, right? That color space is this purple box. Okay, no, okay, no, that color box is this one, this purple triangle. So if you want to represent some color here, you can use CMYK color space, and these color spaces are altered. Like you can change the color spaces in OpenCV. Okay. So image thresholding, smoothing images you already know that from where that is, oh here, right? Smoothing images looks like this, blur. So this is the operator. This is the operator that is getting performed with the like that is basically getting multiplied with the image. So yeah, if I apply this blur, this kernel on the image, it computes this blurry image from this hard image. Okay. Okay, so wait, what was our topic? Okay, and then the sentiment analysis, right? So OpenCV you can try and like learn more. So we'll kind of cover all the image processing steps in the next weeks. Yeah, okay, how I can apply like let's say edge detection, how I can apply smoothing, all those things, or how I can flip. So there are many transformations that can happen on a image. So for example, these are known as augmentation, sometime image augmentations also. So yeah, so you can just see how many augmentations are possible. These are some type of augmentation you can do on a cat image. You see, you can have the original image, right, make it brighter, add some Gaussian noise or vertically flip it, right, make it darker or rotate by 45 degree. These type of processings are done to kind of increase the data set. So whenever you have, let's say, limited number of images, let's say per class you have 50 images, okay, and usually a deep learning model doesn't get good accuracy if the data for each class is below 1000, okay. So you have to make the data such like 2000 classes, right? So each class have to have 1000 examples. So what you do, let's say you have 50 and 50, so how many augmentations you need on average? 1000 divided by 50, right? 20. So you can apply 20 different image processing techniques or 20 different augmentation on the same image, or let's say combination of them, let's say flip and then bright, or let's say rotate and then crop. These type of augmentations you can apply and have total 20 combinations, right, which will increase your data set to be 1000 from 50. So it will not necessarily increase the quality of the data because it's still a white cat, right? It's still a image of a white cat, but it will definitely increase the, like, it will definitely improve the model performance later on. So whenever you are training some deep learning model on that image, given you train on 50 images and given you train on 1000 images or augmented from 50 images, the later on will be always better. Okay. Okay guys, so I guess we already reached 8:05, so fine. So today we covered only the kind of basic of image processing. We'll show some of these things how we can apply image processing. Maybe later on in the data processing class or some other class, we can also show you a kind of very small use case of image classification or something with Python. Okay, whether I can classify whether it is a dog or a cat. Okay, and like the sentiment analysis is very simple, so we'll just touch it on the next class. Okay, so it's basically, so I can give you an overview. So it's basically whether a, so how it came into picture. Let's say we all write reviews on Amazon, right? We write reviews on Amazon. Okay, this product is like trash, this product is very, like, very good, this kind of reviews. So so let's say you, so the Amazon can always give you a star rating, right? So this star rating to give on a product, that you may skip, right? You may skip giving the star rating of a product, but if it is good, you can, it's higher probability that you should write the review, okay, it's good, or some if somebody has disliked it, they should write, okay, it's very bad, something like this, or okay, I face these type of challenges when I buy this device, something like this, right? So from that sentence, whether I can identify whether the person was happy or whether it is a positive review or whether it is a negative review, without that star rating, right? Okay, anyway you give the star rating, but sometimes it happens that, okay, you give star rating as 5, but there is something you feel off with the product, so you write that thing in the comment. Okay, I think the overall packaging of the device is good, but I don't like how how the charging is very slow. Okay, so or let's say the discharge is very quick, these type of things. So even though you like the overall packaging, but you don't like whether the, like, don't like that the battery is very short lived. So these type of signals is only captured from the comment, right? So the sentiment analysis came from this idea. Okay, people write reviews, and those give her better insights on whether he likes or dislikes the product instead of only a scalar star rating. Sometimes it happens to me, right? That, and you guys may have also feel it, that you like the overall product, but there is something off with the product. You write that in the comment. Okay, okay, everything is fine, but I don't like this, right? So even though you give a high star rating, there is something you don't like about the product. These things, or these reviews, the let's say the vendor, right? The vendor has to listen to these reviews. So from all, let's say 10 million reviews, he can identify which are negative reviews and work on them, right? Okay, okay, my people are not liking my short-lived battery life, so I can improve my battery life in the next version. These type of things. Okay, so we'll touch upon like sentiment analysis and all in the next class. So in the next class we will only do OpenCV, so image processing and all, and then sentiment analysis. Okay, and next class we will do the data analytics. So because we already covered most of it, so we'll do the data analytics after that. Okay, and I don't think there will be lot of new topics introduced to your course material as well. So it's better to know the data analytics part after that. Okay, any questions, guys? Okay, thank you. Then I'll upload the video in YouTube. You can just yeah, if you want to remind, like, revisit something, you can go to the YouTube channel and see. Okay, bye bye. I'm closing the call. Let me just stop
Thank
recording
you.
the, yeah, stop recording the session. Stop.